Right, yesterday we did what is an acid and a base, the Arrhenius definition and the Bronsted-Lowry definition. We looked at common acids and common bases. And then we looked at some acids ionize and some acids undergo dissociation, acids and bases. Some of them ionize and others undergo dissociation, right? And then we looked at examples of, for example, HCl, when it reacts with H2O, it forms H3O plus Cl minus. And then we looked at NH3 as another example. And then did we do the base? Dissociation, ionization, dissociation, right? This is the other one we did. NaOH, when it reacts with water, it forms Na plus OH minus. So this is a dissociation reaction of a base where NaOH becomes Na plus OH minus. Then we also looked at conjugate acid-base pairs. We said HCl, what Cl minus, HCl is your acid, Cl minus is your base. The H2O becomes H3O plus, H3O plus is your acid, and H2O is your base. And then we looked at how because the H plus is donated from the HCl to the H2O. That's why it becomes Cl minus and H3O plus. So this is the work we did yesterday. You had to do some homework. I hope there was no problems with your homework. So we'll continue today now, right? We need a conjugate acid-base pairs. Let's look at an ampholyte. So in your books, I want you to write down this reaction. An ampholyte is a substance that can act as an acid or a base. So how is it possible for a substance to act as an acid or a base? So here's one example, right? If you look at H2O as an example, we see that if you take H2O and you put HCl plus H2O, it becomes H3O plus Cl minus. No? And then if you look at NH3 plus H2O, it becomes NH4 plus OH minus. All right. So what I want you to do now is work out the conjugate acid-base pairs in your books. So work it out for me. Let's see what we get. Right, so if we look at the answer for that, which we may have did yesterday, if you look at the HCl plus H2O, we're just focusing on the H2O now, right? So in this case, if you look at HCl plus H2O, the H2O acts as a base. Then if you look at the other example, when NH3 acts with H2O, the H2O acts as an acid. So we see from this that in some cases, HCl can act as a base, like in this case, it's a base one, base, I'll just put base depending on that. And then in this case here, we see that it acts as an acid. So when a substance can act as a base in one example and an acid in another example, then it is called an ampholyte. I'm going to give you some time, but not now. You're going to look at HSO4 minus. So write in your books HSO4 minus and try it out to see how it can act as an acid or a base. To give you a clue, you start off what? H2SO4. All right, but we're not doing it now. I'm just going to move on, but we can get back to it during question time. All right. Now, the next point I'd like to highlight is strong acids and weak acids. What's the difference between a strong acid and a weak acid? So if you look at a definition, a strong acid completely ionizes in water. Example, nitric acid. So a strong acid completely ionizes in water. Example, nitric acid. For example, if you get HNO3 plus H2O, it forms H3O plus NO3 minus, right? And we remember the aqueous signs are there. Now, if you look at the arrows that we have here, we see that the forward reaction is a long arrow because most, if not all, of the forward reaction takes place and a little bit of the reverse reaction takes place. So the HNO3, most of it becomes H3O plus, right? So because most of it ionizes to H3O plus, it is called a strong acid. A strong acid ionizes almost completely, right? Then if you take another example, a weak acid ionizes partially in water. So if you take CH3COOH, which is ethanoic acid, which you know as vinegar, if you put it in water, the forward reaction is a little bit small, slow, a little bit of it takes place, but the reverse reaction is the greater reaction. So the amount of H3O plus formed in this case will be a little. As a result, we see that CH3COOH, ethanoic acid, is a weak acid. Now, if you take it further, what's the difference between a concentrated acid and a dilute acid? So, a concentrated acid has a high number of acid in a small number of water. It refers to the number of moles of acid or base in water. Like we did the equation, right? What was the equation? The equation was concentration is equals to number of moles over volume, right? I'm going to save time for that. Number of moles over volume. So if you have a high number of moles in a certain volume, then you have a concentrated acid. If you have a low number of moles in a specific volume, then it will be a dilute acid. Now here's another question. Can you get a concentrated acid that's or base or concentrated, or can you get a concentrated weak base or a dilute strong base? Is it possible? Can you get a concentrated weak base? Not say weak, do you rather say concentrated weak base? So what's a weak base? Any idea? You know what's a concentrated weak base, anyone? Concentrated weak base or dilute strong base. So to do that, we can say a concentrated weak base. A weak base, for example, will be ammonium carbonate. All right, that you have to learn. That will be given to you. All right, you don't have to learn it. So ammonium carbonate is a weak base. So all you have to know is if you have a concentrated weak base, that means it will be a weak base, but there'll be a high moles in water. So it's possible you can get this. All right, so you can get it, yes. You can get a weak base, for example, ammonium carbonate. It's a weak base, but it can be concentrated if you put a lot of it in small amount of water. Right. So that's what we know, and we can also get a dilute strong base. Also, we can get a dilute strong base. For example, a dilute strong base will be what? Dilute strong base. For example, which is a strong base that we know the most popular is the one you use in soap, NaOH. And if you look at the NaOH, we can have a dilute strong base. You have a little bit of soap in a high amount of water, right? Let's just put this properly. So it will be low moles in high concentration of water. So low number of moles in high concentration of water will make it a dilute strong base. Okay, so I just wanted to highlight that again. A strong acid and a weak acid. A strong acid is just its nature. one that ionizes completely, and a weak acid is one, or base is one that ionizes partially. So that you'll get a list of acids and bases, right? If you look at the examples we did here, hydrochloric acid is strong acid, H2SO4 is a strong acid, nitric acid is a strong acid, acetic acid is a weak acid. They'll give it to you. Here, sodium hydroxide is strong, and for example, NaHCO3 is weak, right? So they'll give you that to you. Going further now, we get different types of reactions. For example, if you get an acid, reactions of acid plus metal, it gives you salt plus hydrogen. So these are general rules. You should know them, right? You did this in grade 10, I'm sure. But if not, write it down. An acid plus a metal will give you salt plus hydrogen. Acid plus metal oxide will give you salt plus water. So if you look at this first one, metal oxide got what extra compared to the first one? There's an extra oxygen in the second one, right? So here in the second one, we got salt, which is the same. If you got hydrogen and if you add extra oxygen that was supplied in the reactants, if you add extra oxygen to the hydrogen, you'll get water. Acid plus metal hydroxide will be salt plus water. We'll do a titration for that to show that on one of the days. Acid plus carbonate will give you salt plus water. The carbonate means the CO3. So part of the CO3 will become carbon dioxide, CO2, which you must balance. And acid plus ammonia will give you an ammonium salt. So that's a specific example, right? Acid plus base just gives you the salt. The ammonium salt is formed, for example, I'll just give you the example here. The acid, if you can have HCl, and it reacts with ammonia, then what happens is you get ammonium salt. It just combines to form ammonium chloride. Right, so if you put this down, you get ammonium chloride, which is NaH4Cl. So you only form ammonium chloride. So there's a case where the two just combine to form the salt. All right. So that's something else which you should also remember. Okay, I hope you're with me. We're going on further. Preparing salts. All right. So then he'll ask you, okay, we want to prepare salt, like you did this when you did the fertilizers. If you want to make ammonium nitrate, which acid will you use? And which base will you use? So you'll have to use ammonia plus nitric acid to form ammonium nitrate, right? So some of the salts that we can use, for example, let's look at, we're looking at this as the general equations. We're looking at examples here now, right? So acid plus metal gives you salt plus hydrogen. HCl plus zinc, acid plus metal gives you zinc chloride as your salt plus hydrogen. Acid plus metal oxide gives you salt plus water. If you look at acid plus metal oxide, will give you salt plus water. So NaHNO3 plus Na2O, sodium oxide, will give you salt, sodium nitrate plus H2O. Can you see the difference here? We just add the oxygen, but you must remember to balance it, right? If you look acid plus metal hydroxide, you get salt plus water, acid, phosphoric acid, which we didn't do before, plus KOH, which is your base, will give you potassium phosphate plus water, salt, this is your salt, plus your water. Then salt plus carbonate, acid plus carbonate will give you salt, acid plus carbonate gives you salt, water plus carbon dioxide, acid, H2SO4 plus carbonate, copper carbonate will give you copper sulfate, salt, plus H2O, water, plus CO2, which has to be balanced, that we have to check. And acid plus ammonia will give you the ammonium salt. We did that on HCl plus NH3 gives you NH4Cl. Okay, now we won't do the titrations. I think we're going to be pushing it a lot. I want you to look at your textbook and we can look at some examples of salts and concentrated and weak acids.